So for the first part of the video homework, let's talk about problem 1. So problem 1, we have two probability density function as fx and fy. And we know that z equals x plus y. So we are required to find the density function of z. And the first problem, we're required to use the convolution method. So we know the equality as is if z equals x plus y, then the density function of z equals the convolution of two density function x and y, which is the integral of fx alpha fy z minus alpha d alpha. Okay. So this is it. Then let's take the density function into this two equation right here. So we have that integral from minus infinity to plus infinity, and the first density function So because we know that this is a step function u, so we can transfer this integral to several parts, which is the first part from e to z, and the u alpha minus 1, and the u z minus alpha. Right, because in this integral function, alpha should be larger than 1 and smaller than z. So let's go to the next part, which is from 1 to z minus 1. And in this function, we know that alpha is larger than 1 and smaller than z minus 1. And next part, from 2 to z. Alpha is larger than 2 and smaller than z. Alpha is larger than 2 and smaller than z minus 1. Okay. And these are all easy integral because this step function, the result of step function is always 1. So we have z minus 1. But we have a requirement to each integral. Right here we have the requirement that z has to be larger than 1. And right here, z minus 1 larger than 1. We have z larger than 2. And right here, z larger than 2. And z larger than 3. Right? So we can use the step function to express this requirement. So the first part, z minus 1, and the step function z minus 1 plus minus z minus 2, and step function z minus 2. Z minus 2, step function also z minus 2 plus z minus 3, step function z minus 3. Right. So this is the result of this convolution method. And then we have to use another method. It's geometric method. So we have to draw the figure in this problem. As we all know, the mass function of z is probability z smaller or equal than z, and it's the probability of x plus 1 smaller or equal to z, right? So we have the definition region of x and y from the, we can get the definition region from this 2 density function. Right, so x is from 1 to 2 and y is from 0 to 1. So we can draw the definition region figure right here. X from 1 to 2 and y from 0 to 1, which is this part, right? So then we express z with this x plus 1, so we have to draw the line of x plus 1. For example, when x plus 1 equals 0, we have a line like this, right? And the location of this line, they depend on the value of z, right? Depend on the value of z. So there are several different situations. The first one is that when z is smaller than 1, we have the figure like this. The definition region 1, 2, 1, smaller than 1, z is smaller than 1. This is z, this is also z, right? At this part we can see that there is no intersection between this line and this region, so the probability should be 0. And then let's talk about another situation when z is larger than 1 and smaller or equal to 2. Also definition region 1, 2, 1. Z is larger than 1 and smaller than 2, so it should be like this. This is z, this is z, okay. And in this part we know that this, the area of this triangle should be the probability of z, right? So it's the area of this triangle is z minus 1 to 2 over 2. Okay, and then we take the derivative of this mass function. We have the density function as z minus 1. And the next situation is when z is larger than 2. call this region. And when z is larger than 2, it should be like this, right? Z is larger than 2. Oh, no, it's not like this. I had got a mistake. So because this part is for z to be larger than 2 and smaller than 3, so this line still has an intersection area with this definition region. So it should be like this. Oops. It should be like this. This is 2, this is 3. Yeah, like this, right? So the area of this part is the probability. Oh, we have f(v) equals 1 minus 3 minus z to 2. This is z, and over 2. And the density function is 3 minus z. Okay, so, and it's easy to see that when z is larger than 3, the FZD should be 1. Okay, then we can write down the density function of z. It's z minus 1 when z is larger than 1 and smaller than 2, right? So we can use the step function to express this requirement, to express this region. Yeah. Minus u z minus 2. Okay, plus, and 3 minus z when z is larger than 2 and smaller than 3, so 3 minus z larger than 2, smaller than 3. So this is the same as the previous method. We just have to do one more step calculation. It's z minus 1. Okay, that's it. This is the answer. So thanks. That's all about the first part of the video homework.